This fastmcp.json configuration file defines everything needed to package and deploy your fastmcp server, from the entry point to all dependencies, using a standardized schema that enables IDE validation and documentation. We'll break down how this declarative configuration works. The mandatory source section specifies your server file and entry point, while the optional environment section declares dependencies that will be automatically installed. You'll see how the schema reference enables rich editor support, how default types like file system for source and UV for environment simplify the configuration, and how this approach replaces manual CLI arguments while supporting multiple environments and deployment scenarios. The closing braces properly terminate each section and the root configuration, creating a complete, portable definition of your server that works consistently across different systems.
Schema https://gofastum.com/public/schemas/fastmcp JSON/v1 JSON. Source path server pi entrypoint MCP environment dependencies pandas requests.
This demonstrates the configuration as code pattern for AI tool deployment, using a standardized JSON schema to define execution environments. The manifest declares three core components: source location for the MCP server entry point, environment dependencies managed via UV, and optional deployment settings for runtime behavior. Unlike traditional CLI arguments or environment variables, this approach creates a version-controlled, IDE-friendly specification that replaces manual setup with declarative metadata. The pattern works through structured separation of concerns across three configurable sections. The mandatory source block, defaulting to file system type, points to your server implementation, while the optional environment block, defaulting to UV type, manages dependencies either inline or via requirements files. An additional deployment section handles transport-specific settings like SDDIO versus HTTP, enabling the same configuration to work across local development and production environments. This hierarchy allows tools to specify Python version constraints, multiple environment profiles, and transport methods without modifying application code. This approach solves environment consistency challenges for AI integrations by replacing implicit setup with explicit versioned configuration. Teams gain IDE validation, inline documentation, and repeatable deployments across different transports, while the separation from application logic enables clean upgrades. The pattern particularly benefits scenarios requiring multiple environment profiles, or where CLI arguments become unwieldy, though it adds initial setup overhead compared to ad hoc configuration methods. Let's break it down line by line. This defines a fastmcp configuration file using JSON schema validation. The schema reference enables IDE auto-completion and inline documentation while enforcing structural correctness. The source section specifies the entry file, server, pi, and initialization function, MCP, with an implicit type, file system, default. The optional environment section declares Python dependencies using an implicit type, UV manager supporting either inline packages or requirements files. A separate deployment section, not shown, would handle runtime settings like transport method, SDDIO/HTTP, and Python version constraints. This configuration as code approach replaces CLI arguments, supports dev/prod environments through separate files, and ensures reproducible deployments across machines.
Schema https://gofastum.com/public/schemas/fastmcp JSON/v1 JSON.
This JSON schema reference enables IDE validation, auto-completion, and inline documentation. It enforces fastmcp's configuration structure while supporting optional fields like source type, defaults to file system, and environment type, defaults to UV. The configuration follows fastmcp's declarative pattern, replacing CLI arguments with version-controlled settings. It supports multiple environments, dev/prod, Python version constraints, and alternative dependency sources like requirements files.
Source.
The source key declares your fastmcp tool's entry point configuration. It specifies the Python file containing your MCP server implementation via path and the initialization function through entrypoint, while implicitly using the default type, file system, for local file execution. This mandatory section replaces CLI arguments with declarative configuration as code, enabling consistent execution across environments.
Path server py.
Specifies the Python module containing your MCP tool implementation. This path directs fastmcp to the exact file with your @mcp tool decorated functions, while the optional source type, defaulting to file system, defines how to load it. Without this, the server wouldn't locate your tool definitions during startup.
Entrypoint MCP.
Defines fastmcp's execution entry point. The server locates this MCP, callable, function, class, or instance as the root request handler, routing all incoming AI calls through it. This follows fastmcp's standard pattern where the entry point becomes the central processor for tool execution, replacing CLI-based initialization. This closing brace finalizes the root configuration object, completing the JSON structure. It ensures proper parsing against the schema while enabling IDE features like validation and inline documentation. The configuration supports optional sections like deployment for runtime settings, with source type defaulting to file system and environment type to UV when unspecified.
Environment.
The environment key declares runtime requirements using fastmcp's configuration as code approach. It replaces CLI arguments by specifying Python dependencies, version constraints, and environment variables in a reproducible format. The schema supports inline dependencies or requirements files, with type defaulting to UV for package management.
Dependencies, pandas, requests.
Declares the Python package dependencies required for this fastmcp tool. The environment manager automatically installs pandas for data manipulation and requests for HTTP operations before execution, ensuring consistent runtime environments. This uses the default UV environment type, though you could specify alternatives like pip or reference requirements files for production deployments. This closing brace terminates the root JSON configuration object, finalizing the fastmcp tool definition. The schema reference enables IDE validation and auto-completion, while the structure supports optional sections. Source defaults to file system type, environment defaults to UV, can use requirements files, and deployment for runtime settings like transport protocols. The configuration as code approach replaces CLI arguments, handles Python version requirements, and supports environment-specific files for dev/prod separation. This closing brace terminates the root JSON configuration object, finalizing the fastmcp deployment specification. The schema reference enables IDE validation, auto-completion, and inline documentation, while the configuration itself replaces CLI arguments with declarative, version-controlled settings. The structure supports optional sections. Source defaults to file system type for entry point definition. Environment defaults to UV package management for dependencies, and deployment for runtime settings like transport protocol. This approach handles multi-environment setups through separate files and eliminates works on my machine issues by codifying all requirements. fastmcp configuration pattern. The JSON schema reference enables IDE superpowers like autocomplete, validation, and inline documentation, while maintaining a clean separation between source location, environment requirements, and deployment settings. Source type defaults to file system and environment type defaults to UV when unspecified, with only the source path being mandatory, while environment and deployment remain optional configuration blocks. This declarative approach replaces CLI arguments, supports multiple environments through separate files, and handles different transports via the deployment section.
The configuration that names every requirement becomes nameless in execution.